Alright, so this video is going to be about ionic bonding and nomenclature of ionic compounds. So again, we've been talking about compounds and molecules in this chapter, and there's a slight difference between them. Compounds are substances that are composed of atoms of two or more elements. So you have to, in a compound, you have to have two different elements. And they are chemically united, so meaning that there's a bond between these elements, and they exist in fixed proportions. And then a molecule is a little different. You have to have two or more atoms, but they don't have to be different elements. They're chemically bonded, usually covalent bonded, and they exist as a single units. So like H2O, two hydrogens and one oxygen, is a molecule. They're covalently bonded together, and they exist as single units. Unlike Na sodium chloride or something like that. So as we go through these, we'll learn a little bit more about these two terms. So in this chapter, we are looking at three different types of compounds: ionic compounds, binary molecular compounds, and acids. In this video, we'll be dealing with ionic compounds, and there's two other videos to deal with the other two. So if we remember, we can interact sodium and chlorine. So sodium, remember the Lewis symbol for sodium is Na with one dot, because Na is a alkali metal, and Cl is a halogen. So it has 7 valence electrons. And when these come together, the nonmetal is going to pull the electron from the metal. And in doing so, the sodium now has lost an electron, so it's got one more proton than an electron, so it's become an ion. And chlorine has gained an electron, so it now has one more electron than proton, so it's negatively charged. We draw the Lewis symbol with all the dots around it and brackets around it to show that those dots are part of the chlorine and the charge on the outside. So when these two interact, it's a pretty high energy reaction. There's quite a bit of energy that's released, and you form the sodium ion and the chlorine ion. And because they're oppositely charged, they're going to be attracted to each other, and we would show the Lewis symbol for this, or the Lewis structure for this, as sodium plus and chlorine minus, with chlorine having all the valence electrons around it. And you can see now why we would put that bracket there, because if we didn't have that there, those two electrons, they're kind of between the sodium and the chlorine, we wouldn't know which atom or which ion they're with. Now we know. Those electrons are with the chlorine. So what we're going to do is look at these kind of interactions and compounds where the ions are attracted to each other because they're opposite charges. So this interaction between the sodium plus ion and the chlorine minus ion is known as a ionic bond, and it exists because of the opposite charges. The opposite charged ions are attracted to each other. Right, so sodium and chlorine, so the molecule that we just saw, let's go back once. And the formula, if we were just going to write it in general without showing the Lewis symbol for these, would just be NaCl. So for ionic compounds, we write the formula where overall it's neutral. So if I take a Na plus and a Cl minus, the plus and the minus neutralize each other, and I get NaCl as a neutral system. So what we're doing when we write the formula is making sure that I've got the right ratio of cations to anions to make it neutral. So in a sodium chloride crystal, which is what these are, you can see down here, that's a small crystal that we've zoomed in on of sodium chloride. Up here is just a pile of it. Since sodium chloride is table salt, that's what we're looking at. And you can see this is what kind of a crystal looks like where we've got the purple ones, which are the sodium ions, and the green ones, which are the chlorine ions. And the sodium ions are smaller because they've lost an electron, so now they got more protons than electrons, and those protons can pull those electrons closer to the nucleus, while chlorine has gained an electron, so it's got more electrons than protons, so it gets a little bit bigger. But you can see in the crystal that there's one sodium for every one chlorine, all throughout the crystal. What if we do magnesium and bromine? Now, magnesium is an alkaline earth metal, so it's got 2 valence electrons. Bromine is a halogen, so it's got 7 again, just like chlorine. And when magnesium and a magnesium atom and a bromine atom interact, the bromine pulls one of the electrons away, and I get the ion of bromine, now with 8 electrons around, so it's got 1 extra electron. And magnesium still has 1 electron, so it needs to lose both because it's going to be a 2+ ion. So what will happen is another bromine will take that extra valence electron and become another Br- ion. And the Mg will end up as Mg2+. And you can see, again, we've got a 2+ ion and 2 negative ions. So these are going to be attracted to each other. Notice that the 2+ and there's 2 Brs, 2 Br minuses that form from it. And each of those bromine ions is a single negative. So if I put the 2 together, I got 2 negative charges. Mg has 2 positive charges. So the formula of the compound that's formed between magnesium and bromine is MgBr2. Okay, so in a crystal of this, there'd be 1 bromine for every 2, or excuse me, 1 magnesium for every 2 bromines that were in that crystal, in that ionic crystal. Okay, if we're going to draw the Lewis symbol, or the Lewis structure for this, we would put an Mg2+, a Br-, and then we'd probably draw another Br- on the other side. It would be kind of weird to draw the Br- on the other side of the Br- because they're not actually, they don't interact favorably. So we're going to draw it so they interact favorably, so we can see the favorable interactions. Okay, so simply from the charges, we can predict the overall formula for the ionic compound. So for formulas for ionic compounds are neutral. So we determine formulas of ionic compounds by ensuring the ratio of cations to anions gives a neutral system. So we get a formula where the number of cations, the number of positive charges equals the number of negative charges from the anions. When we name ionic compounds, we simply take the name of the cation, the positively charged species, and the name of the anion, the negatively charged species. So if you've already watched the video for the binary molecular compounds, in those we have to tell in the name, we have to use a prefix to show how many of each atom there are. For ionic compounds, we don't do that. We simply can figure out the formula based on the names of the ions because we know the charges of the ions and we can come up with a neutral formula. So most cations are simply ions of metals. So the cations, most of the cations we're going to see 2 that are not metals, but really we're only going to use 1 of them. So when we have an ionic compound, we basically have a metal as the cation. So if you see a metal as the first thing in the formula or the first thing in the name, you know it's an ionic compound. And then, oops. Probably should finish the names of the cations. When we're naming cations, it's simply the name of the metal. So for example, Na+, that's called the sodium ion. And Mg2+, it's called the magnesium ion. Al3 plus. That's called the aluminum ion. Okay. For transition metals that have more than one stable ion, like copper, so copper's got a plus and a 2 plus ion, in the name we have to tell you the charge because there's no other way to know. So for example, Cu plus is called the copper 1 ion, and the 1 is Roman numeral in parentheses right after the R. So copper 1 ion, and Cu2 plus is called the copper 2 ion, where the Roman numerals tell you the charge of the ion. So copper 1 ion is Cu plus, copper 2 ion is the Cu2 plus ion. Okay, the Roman numerals are the charge. So if you haven't used Roman numerals before, they're fairly straightforward. I is 1, I is 2, I is 3, IV is 4, V is 5, and like VI 6, VII 7, and so on. Okay, so those are the Roman numerals we'll use that are in the parentheses to show us the charge of the ions. Okay, the other one would be like tin. Tin has a 2 plus and a 4 plus. So when we name those, the 2 plus is going to be called the tin 2 ion, and the 4 plus is going to be called the tin 4 ion. Okay, where the Roman numeral is just the charge of the ion you're dealing with. In the old days, we used the Latin term. So copper is cuprum in Latin, C-U-P-R-U-M. So that's where the Cu comes from. But when we had ions back in the day, the lowest charged one would have an OUS end, and the highest charge would have an IC. So like Cu plus would be cuprous, and Cu2 plus would be cupric. We don't do that really anymore. You'll still see it a little bit around on labels and things like that, but we're going to do the Roman numerals. Okay, so that's how we name cations, just like that. Anions, if we're talking single element, meaning that, like, we had Cl minus, we basically call it chlor and then end it in IDE. So Cl minus is called the chloride ion. So if we have an element that has ions, an element by itself like Cl, we end the ending of the name is IDE. So for example, F minus is called the fluoride ion. O2 minus, that's oxygen's ion. It's called the oxide ion. S2 minus is called the sulfide ion. I minus is called the iodide ion. N3 minus is called the nitride ion. Okay, so you can see that if we've got just single elements, chlorine, fluorine, oxygen, sulfur, iodine, nitrogen, that when they form ions, we're just going to name the ion as IDE at the end. So, I have examples here. This one we saw in the beginning, and that was the NaCl. We're going to call that sodium because it's made of sodium ions and chloride ions. So we're going to call that, NaCl is going to be called sodium chloride. Name of the cation, name of the anion. Okay. What if I do CaF2? Okay, so Ca is a alkaline earth metal. It's 2 plus. F's are each minus, and there's 2 of them. So we can see that the minuses from the 2 F's total 2 negative, and that cancels out the 2 positive from the calcium. So that's why the ratio is 1 calcium to 2 fluorines. So if we're going to name that, that's going to be called calcium fluoride, where our cation is calcium, so it's called the calcium ion, and the anion is called fluoride. We just put the two together. And you can see in this the fact that for every one calcium, there's 2 fluorines, right? CaF2. So in a crystal of that, you can see you would have that same thing. So it's not as nice and evenly packed as the sodium chloride, but there's still a significant structure to it. All right, if we do another one like FeBr3, Br is a halogen, and each Br is a negative, and there's 3 of them, so overall it's 3 negative. So Fe, there's only one Fe, which is iron, and because there's only one and there's 3 negatives, that Fe has to have all the positives, so the Fe is 3+. And iron is a transition metal, so we have to write that 3+ in Roman numerals. So we're going to call it iron 3 bromide. Okay, because we have bromines by themselves. There's no other. That's the only anion here, are the bromines, so we call it bromide. So iron 3 is Fe3+, bromide is the Br-. So when we're naming ionic compounds, name the cation and name the anion. Now, if you've watched the binary molecular video, binary molecular compound video, we saw that we can covalently bond things together. And there are times when we covalently bond things together and they gain an extra electron or 2 or 3, or they lose electrons to become more stable. For example, NO3, nitrogen trioxide, right? I'm just going to draw this where there's, if you've watched, the N and the O's share electrons. And in this case, if I was going to draw them, the N and the O, if we count the electrons, the valence electrons, there's 18 plus 5, 23. There's 23 electrons that I would put in this structure between the N and the O. But if you watch the other video, we know that these atoms want to get 8 electrons around them. And if there's 23 electrons, one of them is going to have an odd number, which is not 8, because 8 is even. So when NO3 bonds together, if we can find an extra electron to pick up, it will do that. And we'll draw this in the next chapter. So it picks up an extra electron. When it does that, it now has more electrons than protons, and we put a negative charge above it. This is known as a polyatomic ion. Poly meaning many, atomic meaning atoms. So we've got a nitrogen and 3 oxygens that are all covalently bonded together, meaning that they're sharing electrons. And there's one extra electron in the system. That negative tells us that. So NO3 is an ion. So when NO3 wants to bond, it wants to find a positively charged ion, a cation, to interact with. So for example, if an Na plus comes around, the two are going to be attracted to each other. I'm going to get Na, NO3. One of each, because NO3 is minus, Na is plus. So I'm going to get one of each. And the formula for that ionic compound, right, it's made of cations and anions, is going to be NaNO3. So we're going to have to deal with a set of polyatomic ions. These systems where the atoms are covalently bonded together, but they've either gained or lost electrons to make them more stable. So this is the list of polyatomic ions you need to know. And actually there's some at the top that are not polyatomic, but those are the ones we discussed before. Fluoride is F-, chloride is Cl-, and so on. So those are all the single element ions. It's these ones down here that we're going to add. Those are called polyatomic, and you can see they all have more than one atom. Hydroxide is OH minus, cyanide is CN minus, nitrate is NO3 minus, and so on. Now, when I was in school, I just learned these. We memorized. I'm terrible at memorization, but I finally got it down. It just takes a little while. Nowadays, there's like mnemonics for this, but I don't know any of them because I don't need to, because I just got them memorized. But if you want a mnemonic for remembering some of these, go to the Science Learning Center. They definitely have several mnemonics that you can do. Okay, but if we look at these, a lot of these are an element and oxygen. So nitrate, for example, is 1 nitrogen and 3 oxygens. Nitrite is 1 nitrogen and 2 oxygens, and so on. These kind of things are called oxyanions. And oxyanions are anions that are polyatomic. They have more than one atom, and they have oxygen and something else. For example, nitrate is nitrogen and oxygen. Nitrite is also nitrogen and oxygen, but in different ratios. Chlorate is Cl minus or ClO3 minus, so chlorine and oxygen. Carbonate is carbonate and oxygen. Okay, so a lot of these are simply an element with oxygen. And you can see there's some that have ATE at the end and some that have ITE. There's no really rhyme or reason to this other than the fact that the ATE one is the one that's most prevalent in nature. So nitrate we would find more in nature than nitrite. Okay, the difference between the ates and the ites, so nitrate and nitrite, is simply a loss of an oxygen. So the nitrite has one less oxygen than the nitrate. It's still the same charge, but it's lost in oxygen. Okay, and then we've got more down here, and then we've got the ammonium ion. And the ammonium ion is NH4+. Okay, and so that's a cation. So up to this point, the only cations we had were metals. This is another cation. This will bond to any anions. So our cations, when we're looking to determine if our compound is ionic, if it's a metal or ammonium, NH4+, NH4, then we have an ionic compound. Okay, so you just need to learn these elements, or these polyatomic ions. You need to know these. You need to know them for naming. You need to know them as we go forward. I think I have, I don't remember what it's called. The app that does flashcards. I think I've got these loaded into one of those. If I do, I will post that. So continuing on. Why isn't it continuing on? Oh, there we go. So we're going to look at some examples here. Again, when you first look at a compound, you need to figure out what type of compound it is. Is it an ionic compound? Is it binary molecular? Is it an acid? Okay. Remember, ionic compounds, the first thing is a metal or ammonium. You can see NH4 there. Okay. So all of these are ionic. Magnesium, potassium, aluminum, sodium, ammonium, iron. They're all either metals or ammonium. Okay, so those are all cations. So now we're going to name these. Remember, when you name an ionic compound, it's just the name of the cation and the name of the anion. So MgSO4. So we can see that it's got Mg2+ in it because that's the ion for magnesium. And then SO4 is the anion. So it's SO4 2-. Because if magnesium is 2+, and there's only one magnesium and one SO4, that means the SO4 has to carry all the negative charge, which is 2-. Notice I didn't separate this into magnesium, sulfur, and oxygen. I kept the anion together. The SO4 comes together. So once you take the metal off, Everything else is the anion. So now we name this. Magnesium is an alkaline earth metal. So it's just got one ion, so magnesium. And SO4 2- is sulfate. We can see it over here. Right there. And you'll know that at some point. So MgSO4 is magnesium sulfate. Okay, next one, K2CO3. We've already identified this as an ionic compound because potassium, K, is a metal. So this is made of K+. Remember, potassium's in the first column, so its ion is just a single positive charge because it's only got one valence electron to give up. And there's two of those. And then, so that must mean the CO3 is 2- because everything else other than the K is the anion. So CO3 2-, there's only one CO3 sitting there. There's no parentheses like down here. There's only one CO3. So if I'm going to name these, K+ is potassium. And CO3 2-, if I go over to the chart, where is it? Right there. CO3 with a 2-, carbonate. Okay, so K2CO3 is potassium carbonate. Right, next one, aluminum. It's a metal. Aluminum's ion is Al3+. We can see the CNs, and there's three of them. So I have a CN-, a CN-, and a CN-. So we have our one aluminum and the three cyanides. Remember, cyanide is sitting right there. CN- is cyanide. And when we name it, we don't have to tell you how many there are. We figure that out because of the charges. So Al is aluminum. And aluminum only has one ion. That's the 3+. And Cn is cyanide. Aluminum, oops, that didn't spell right. Cyanide. There we go. Aluminum cyanide. Notice, it's just the name of the cation, the name of the anion. Okay, it doesn't tell us how many there are. It's not aluminum tricyanide or anything like that. It's aluminum cyanide. Okay, next one, NaHCO3. Na+ is our cation, and then everything else is the anion, CO3-. So Na+ is the sodium ion, so sodium. HCO3- is hydrogen carbonate or bicarbonate. So we call this hydrogen carbonate. Okay, so NaHCO3 is sodium hydrogen carbonate, or sodium bicarbonate. Keep the HCO3- together because it's sitting right there. Right? NH4, remember we said that was ammonium. OH is hydroxide. So this is made of NH4+ and OH- ions. They're 1-to-1 because an NH4+ and an OH- cancel each other out. This is known as ammonium hydroxide. And last one, FeNO33. Fe is a transition metal. So I have Fe, I got to figure out its charge. NO3- nitrate, that's over here, right there. So nitrate is NO3 with a single negative. There's three of them. So that means overall there's three negatives. And iron's all by itself, so that one iron's got to carry all the positives that neutralize this. So iron 3+, nitrate, and we're going to write this as iron 1, 2, 3, iron 3 in Roman numerals, nitrate. Okay, we take the name of the cation and the name of the anion and we put it together. Okay, don't give me like iron nitrogen oxide or something like that. The NO3 is all together. So find the cation and then find the anions. Okay, going the other way. So now we have to come up with something that's neutral as the formula. So calcium is 2 plus. Chromate is CrO4 2 minus, I believe. Yep, CrO4 2 minus. We can see calcium is 2 plus. Chromate is 2 minus. If I put them together, they neutralize. So I'm going to write CaCrO4. No parentheses because there's one of each. One calcium and one chromate. And that's it. Lithium, Li plus. Sulfite, if I go over here, that's SO3 2 minus. And you can see there's 2 negatives and only 1 positive. So I'm going to need a second lithium. So if I'm going to write that, I'm going to write Li2. So there's 2 lithium pluses and an SO3 as the anion. SO3 2 minus is the anion. Lithium, Li. Sulfite, SO3 2 minus. Okay. In the formulas, there are no charges. So once you've got the formula and the ratio between the cations and the anions right, we don't write any charges. Okay. Tin 2 hydroxide. Tin 2 is SN2 plus. Remember the 2 gives us the charge. And then hydroxide up here is OH minus. So if I'm going to make a neutral thing, I have 2 pluses from the tin and a single minus from the OH. So I'm going to need 2 OHs to make it neutral. So I'm going to write SN, and then I'm going to put the OHs in parentheses because I need 2 OHs. Right? So I need 2 hydroxides. Hydroxide's OH minus. So I'm going to write the OH in parentheses. If you only have one of these, we wouldn't write parentheses. But because you need more than one, that's how we do it. Okay, copper 1 phosphate. Copper 1 means we have Cu plus ions. Phosphate down here is PO4 3 minus. Okay, so phosphate is a phosphorus with 4 oxygens and a 3 negative charge. So we can see we have more negative charges than positives. I need 3 copper ions, copper 1 ions to balance out the phosphate. So my formula is going to be Cu3PO4, where there's that subscript 3 shows that I need 3 coppers and 1 phosphate to make something neutral. Right, aluminum sulfate. Al is 3 plus. Sulfate is SO4 2 minus. Interesting. So right now I've got more positives than negatives. So if I add another SO4, that would give me 4 negatives and 3 positives. So I need to add another aluminum. That would give me 6 positives and 4 negatives. So I'm going to add another SO4. And I've got 6 positives and now 2, 4, 6 negatives. So my ratio of aluminum to sulfur is Al2, then SO4 in parentheses 3, because I need 3 of that whole SO4. Right, next one, ammonium oxide. Again, it's an ionic compound because it starts with either a metal or ammonium. Ammonium is NH4 plus. Oxide is O2 minus, right, from up here. So if I got two negatives and a positive, I'm going to need another positive, which means I need 2 ammonias, NH4 2. That gives me 2 NH4 pluses and an O2 minus. So I'm just going to put an O after that. And last one, lead 4 perchlorate. So lead 4 is Pb4 plus. Perchlorate is right here, ClO4 minus. And if I put these together, 4 plus and negatives, I'm going to need 4 negatives. So I need 4 of the perchlorates. So I'm going to write Pb parentheses ClO4 4. Okay, that tells me I've got 4 ClO4s. Each ClO4 is a single minus. So if I got 4 of them, I have 4 minuses, and the lead here is a 4 plus, so that's exactly right. And that's the end. So that's how we do ionic compounds. It's just the cation and the anion's names put together. So if you're given the formulas, you have to figure out the cation and the anion. If you take the cation off, the anion's everything that's left. So remember, if you've got parentheses, you're naming what's inside the parenthesis. Oops. You're naming what's inside the parenthesis. So like aluminum cyanide. And we don't say di, tri, or any of that because we can figure that out based on the charges. Okay, like on the next page. If we're given the name, we figure out the formula.